Dear students, in today's class, let us see arrays of structures. In second module, we have already seen arrays. Okay, in arrays, we can store and process same type of data. If array is declared as int, only integer type of values we can store and process on them. If we declare the array as a float, we can store only floating point of values and we can process them. Here we are talking about now arrays of structures. So when we can use arrays of structures instead of only using structures. In structures there are there may be multiple number of and multiple types of data we can store and process on them. It means we can store integer type of values, floating point of values, and characters. All those types of values we can store in a single structure. Once if we want to use that same structure for multiple number of processing or multiple number of elements, then we have to use arrays of structures. Okay, see here, an array of structures is used in a program whenever the same structure is used for a group processing. Okay, for example, a professor wants to maintain marks of all the students in a class. For that professor, it is very suitable to use arrays of structure instead of a simply a structure. A structure just gives a template, but by using that structure, he can store or he can process on multiple number of marks of multiple number of students. So a professor creates an array of students marks list for all the students in the class. The student marks list structure contains following information. What type of information that professor has to maintain? He has to maintain name, roll number, marks 1, marks 2, marks 3. It means marks of I1, marks of I2, marks of I3. Then he has to store average marks also of that particular student. If there is only one student, then defining or declaring only a structure is enough. But in a class there will be not a single student, there may be many number of students in a class. So to store the names, roll numbers, marks 1, marks 2, marks 3 and average marks of all those students, he has to use arrays of structures. Now we will see how to declare the array of structures. So array of structure, which structure? Student. So here we are going to see now declaration of an array of student structures. See how to see this one. Struct student, open the structure, then these all are data types: int, char and int float. Int roll number, char name of 20, int m1 m2 m3, float average. So here roll number is one data member, member of a structure, and name is a member of a structure, and it can store 20 characters. It means each name can store 20 characters. So it is a string. It is, if this size is not written here, if we have written only char name semicolon, then it will be a character. But here along with this member of structure, we are specifying the size of that name. It means that it is a string, so that each and every student's name can store maximum how many number of characters? 20 characters. And int m1 m2 m3, and average marks will be in terms of floating point, so we have declared it as a float. Then close the structure and put a semicolon. So after that now we have to declare structure variables. So structure variable is here nothing but we are going to maintain a student's marks, so only one variable is enough here. Mm, that is the struct student is taken from here. It is taken from here, that is struct student, and it is a data type. What type of data type it is? It is a user defined data type. It is not a built-in data type like int, float, char. Struct student is a data type which is a user defined data type, and variable is here student marks, that is st marks of 30 semicolon. 30 indicates that how many number of students data you want to maintain. It means that how many number of students are there in a class. So there are 30 students are there. Let us assume that there are 30 students are there in a class. The professor wants to maintain the ia marks, name, roll number, average marks, all those details of all those 30 students. So we can write any number here, no problem. Okay, so how exactly in a memory these data members and variables will be located, or how they are arranged in memory physically, we will see here. See here, it is a array of structures. So first we have written here just a diagram of array like this. First index of array is 0, second index of array is 1, third index of array is 2, like this. Last index of array is 29, because how many students data we are maintaining here? Total 30 students data we are maintaining here. So here, since the array index is starting from 0, last index will be obviously 29. So total 30 locations are there in this array, or 30 cells are there in this array, and each and every cell or each and every memory location is divided into these many number of cells or partitions. That partitions will be first partition will be for roll number, and roll number is of which type? It is integer type. So 2 bytes of memory will be allocated for this rule number for first student. Okay, here R I have written with pencil. I think it is not visible, but it is R here. That is roll number. 2 bytes will be reserved for roll number, and 20 bytes will be reserved for a name of a student. 20 bytes will be reserved for a name of a student, and m1 is again int, so 2 bytes will be reserved for m1. Again 2 bytes will be reserved for m2. Again 2 bytes will be reserved for m3, and 4 bytes will be reserved for average marks. 4 is nothing but it is a size of float is 4. So total for maintaining these all details for a single student, or for a one student, how many number of bytes we require? Here we want 2 bytes. Here we require 20 bytes. 20 plus 2, 22 bytes is over. 22 plus 2, 24, 26, 28 plus 4, that is 32. Total 32 bytes we require to maintain a information of a single student. Same 32 bytes we want to maintain a second student. Same 32 bytes we require to maintain a third student, like this. Okay, like this we will maintain 32 into 30. 32 into 30, that many number of bytes we require in entire this array. Okay, see, this is a declaration creates an array of 30 structures in which each item is of type struct student. So here we are creating how many number of structures? 30 structures. Each student will be maintained by a structure. It means each structure is used to maintain a information of a student. So if we want to maintain a information of 30 students, then we have to maintain, or we have to create, or we have to declare, or we have to define 30 structures. So because of that only it is called as array of structures. There is not only single structure, there are 30 structures are there. In each structure we are maintaining roll number, name, and IA1 marks, IA2 marks, and IA3 marks, and average marks. These many number of details we are maintaining in each structure. Okay, like this we can maintain a details of 30 students. So okay, this example we can see in lab experiment also. Okay, next topic is type diff type define, or type definition. It is called as type definition. Type diff is a keyword. It is used to give a new data type name to already existing or built-in data types like int, float, char, and double. So this is the main purpose of this keyword. When we can use this keyword type def, suppose if there are already some built-in data types are there, already we know this fact, that is int, float, char, double, and so on. So many number of data types are there. These all are called as built-in data types. In the place of these built-in data types, if we want to use any other name, or we want to give any new name to these data types, then we can use this type def keyword. Okay, so if we want to give a new data type name number to int data type, then we can write this statement like this: type def int number. It means that you replace the int by number. This statement says that you replace the int by number. So number also works as a int. So that is type def old name space new name. So now onwards, so you can write number a comma b instead of writing int a comma b. Okay, so first we have to write this statement, that is type def int number. Then directly now you can write number a comma b. Now we will see structure data type, that is creating a structure using type def. With another purpose of this type def is what here, that is second purpose, or second use, or second benefit of this type def keyword. The keyword type def is not only used to give a new data type name to the existing or built-in data types, but it is also used to give new data type name to the user defined data types also. So int, float, char, double are built-in data types. So we have some user defined data types also. For example, struct student, struct book, like this. These all are user defined data types. In the place of these user defined data types also, if we want to write any other new name, we can use this type def. We know that structure is a user defined data type. We can create a structured data type using a type def keyword. Here struct student is there. This is a user defined data type, it is struct student. So here data type is int, and member of structure is roll number. Data type is char, and member is name of 50. Data type is char, member is branch of 50. Data type is float, and variable data member of structure is percentage. Close this structure, and here we are declaring the variables s1 comma s2. Two variables we are declaring, s1 and s2, but the data type of these two variables is struct student. Struct student is not a built-in data type like int, float, char, double. This struct student is a user defined data type, it is. So here student is a structure. The structure type is, the type of that structure is not int, float, char, double. What type of structure it is? Struct student it is. Struct student can be given a structure data type new structure data type name by writing the following statement or below statement. How we can give new name? Type def struct student stud, capital stud, or anything we can write here, no problem. So whenever we want to write struct student, struct student, struct student, instead of writing struct student, struct student, struct student, we can simply write now onwards just stud, that is stood. So after this type definition, the name stud can be used as an abbreviation or short form for the structure struct student. Okay, structure type, it is structure type, which data type of structure it is? Struct student. In the place of struct student, now onwards we can write stud. Okay, so we can declare the structure variables using stud, that is stud diploma student, comma engineering student, stud book, diploma book or engineering book also we can write. And just now previously we had declared their two variables, s1 and s2, so we can write here stud instead of writing struct student. Okay, one example here I have written for your better understanding. Struct student, open that structure, data type is int, member is roll number, data type is char, member is name of 50, data type is char, member is branch of 50, data type is float, member is percentage. Close the structure here, and here write the statement, type def keyword struct student. So here instead of using now onwards struct student, we can simply write stud. With the help of this stud, we can write variables, or we can declare the variables stud s1 comma s2. In another method of defining structure data type, we can write the keyword type def before the structure definition or structure declaration. This is one method till now whatever we have studied. In another method, what we can write here, type def can be written before the structure definition or structure declaration. See, here we are using this type definition after writing the structure, or after declaring the structure, or after defining the structure. That is nothing but after structure definition we are writing this type def statement. But in another method we can write this type def before the structure definition or structure declaration. Then we must write a new name of that structure data type in between right brace and the semicolon as shown in below. So how we can write now in that second method? Type def struct student, left brace, int roll number, char name, char branch, float percentage, and here we are closing. After closing brace or right brace, here instead of putting semicolon, we are writing this data type, that is stud. So what we have done here, instead of simply writing a struct student in this place, we have written type def also here, type def struct student. So if we use type def in before the declaration or definition of a structure, then we can write the data type before closing the semicolon, or before writing the semicolon, that is in between right brace and semicolon. So wherever now onwards this complete statements say that wherever we write struct student as a data type, instead of writing a struct student as data type, now onwards we can simply use stud as a data type. So with this stud data type only, here we are declaring two variables s1 comma s2. Now we can declare any number of structure variables using stud. that is example stud s1 comma s2. So any number of variables, also structure variables, we can declare here, comma s3 comma s4, like this any number of variables we can declare here. Okay, so one programming example also I have given here, hash include stdio.h, hash include string.h. I think you have understood why I am using this header file string.h, because in future of this program I am going to use a string manipulation function or a string handling function. Okay, and here before writing the structure declaration type def, I am using here struct book. Open the structure, char title, char author, int price, int edition, char publisher, and close brace, that is right brace. So after right brace, immediately instead of writing a semicolon, we are writing the data type, so which will be replaced by the, which will replace the data type struct book. Okay, then we are putting semicolon, and data type is book. Along with this data type book, we are declaring one variable, that is bk, and semicolon here. So now we will open the main function, enter the title. How to enter the title? We can use a scanf function also, or else directly we can use strcpy string copy function, which is a string manipulation function or string handling function. So here bk dot title is there. What is this bk dot title? Bk is a variable, and title is a member of this structure. So once this member of a structure wants to become a variable, this member should be linked with this variable, structure variable bk, with the help of a dot operator. So it is bk dot title is a variable. This variable takes its value as a pcd. Okay, so this is a source string and this is a destination string of strcpy function. So or else here, see, I have written here, if we don't want to use this string copy function, then we can directly use scanf input function and read the title. Title is of which type? Char. So I have used here percentage yes, and since it is a string, I have not used any ampersand operator here, because it is not required whenever we read the strings. So directly we write here bk dot title. Percentage yes is nothing but what? Bk dot title. Similarly we will read other variable names, values. So that is printf, enter the author. Author is also string, so string copy bk dot author. Author is kotur. Or else what we can write, instead of writing this second statement, we can write this second statement like this also, scanf percentages bk dot author. So and third value is printf enter publisher. Publisher is also a string. So strcpy bk dot publisher comma sapna in double quotes. So or else by if we don't want to use this one, we can write a scanf again here, scanf percentages comma bk dot publisher also we can write here, we could write here. So then we will read next type of values. Till now we have read, or we have entered three strings. Now we will enter integers. So enter addition of a book. So addition will be in terms of integer, so I have used a format specifier as percentage d here. So you can observe here I have directly written scanf function here instead of using strcpy, because here we are not reading a string, we are reading integer type of value, that is addition. So percentage d is nothing but bk dot addition. So ampersand we have to use here for integers, ampersand bk dot addition. In the address of bk dot addition variable, whatever the value you enter from the keyboard, it will be stored. Or else directly by using one assignment statement with assignment operator also, we can assign or give the value to this variable bk dot addition. How we can give? Suppose addition of the textbook, if you want to enter it as a 2, you can write this statement like this, bk dot addition is equal to 2. this will be assigned to bk dot addition. Similarly, read one more value, that is enter the price, scanf percentage d ampersand bk dot price, or else directly assign 250 price to bk dot price. Now we will print one by one all these values. Printf title is percentages, percentages is nothing but bk dot title, and author is percentages, that is percentages is nothing but bk dot author. Publisher is also percentages, bk dot publisher. Edition is percentages, bk dot edition. Price is percentages, percentages is nothing but again bk dot price, and here we will close the main function. In next class we will see structures within structures or nested structures.